Assalamu alaikum and welcome to e-learning Al Noor International School grade 9 chemistry course. I'm your chemistry teacher Fraz Anjum. This week we will study chapter 7 ionic and metallic bonding, lesson number 3 bonding in metals. For the reference, textbook page number 209 till 212. So please open textbook page number 209. This week in this lesson our main objectives are model the valence electron of metal atoms, describe the arrangement of the atom in a metal, explain the importance of alloy. Metallic bonding and metal properties. How can you model a valence electron of the metal atoms? So start with this metal. Metal consists of the closely packed cations and loosely held valence electrons rather than a neutral atom. Okay, so what is metal? Metal consists of closely packed, means cation is almost packed, but they have a loosely held valence electron in its outermost shell free electron. That's why they can conduct the electricity, okay, rather than the neutral atom. So this valence electron is the main responsible for the conductor. The valence electron of an atom is a pure metal, can be modeled as a sea of electrons. So the valence electrons are mobile and can drift freely from one part of the metal to another part. Okay, so think like this, that thousands or millions of atoms together to form a piece of metal, and on it each atom has a free electron or one or two valence electron, so they can flow everywhere, every part of the metal, from one corner to another corner, so like a sea. So that's why metal is excellent conductor or good conductor. Metallic bond. Metallic bond are the forces of attraction between the free floating valence electron and the positively charged metal ions. So these bonds hold metals together. Okay, so metal bonds are forces of attraction between the free floating electrons and the positively charged metal ions, and because of this attraction these bonds hold metal together. So properties of metals. Metals are good conductor of electric current because electrons can flow freely in the metal. In the previous slide I explained this, okay, because of the valence electron. Okay, so as electron enter one end to the bar of the metal, an equal number of electron leaves the other ends. So that's why it's going to be flow. Flow of electron is called current, electric current, you know this one. So metal are ductile, that is they can drawn into the wire. So second property is metal are ductile. Ductile means, so suppose this is the metal, when we pull it can become a wide shape. So metal also malleable, which means they can hammered and pressed into the shape. Malleable means you hammer it, after hammering become a sheet. Okay, so metal has the property to become a ductile, means become a wire or become a sheet. So ductile means become wire, malleable means after hammering it become a sheet. Okay, now next property is, you can see when the metal is subjected to pressure, the metal cation easily slide past one another. You can see here, when we force it, push it, it slides. Okay, so if an iron crystal is struck with a hammer, the blow tends to push the positive ions close together. The positive ion repels one another and then crystal shattered. You can see here, when you force it, it shattered. How are metal and ionic compound different? How they are similar? Simple thing, both metal and ionic compound form the crystal structure. However, they have different configuration of electron. The sea of electrons surrounding the cation in the metal allow the metal to be ductile and malleable, and ionic crystal will fracture under the pressure. So means ionic crystal, if you hammer it, it becomes shattered, but if you press or hammered the metal, it become sheet or duct. Now, crystalline structure of metal. For sphere of identical size such as metal ions, several closely packed arrangements are possible. These Thai oranges illustrate the pattern called the hexagonal close pack arrangement. So you can see here, you can arrange it. So how many? 1, 2, 3, 4, 5, 6. This shape called hexagonal shape. Okay. So these different arrangement is like this. So in the metal or complete metal, you can find out different kind of shapes there. Now, crystalline structure of the metal. So start with this. In a body center cubic structure, remember we discussed this cubic structure. Body center means the metal, one metal is in, oh sorry, one atom inside the cube. Okay. So in body center cubic structure, every atom except those on the surface has 8 neighbors. The metallic elements sodium, potassium, iron, chromium and tungsten crystallize in the body center cubic pattern. You can see here. Okay. So what it says, in the body center, every atom except those on the surface, okay, has 8 neighbor. Now the different one, in the face center cube arrangement, every atom have 12 neighbor. Face center means every face has a one atom between this. So among the metals that form the face center cubic structure are copper, silver, gold and aluminum, lead. Now in hexagonal close pack arrangement, every atom have 12 neighbor. The pattern is different from the face center cubic arrangement. You can see here metal that have the hexagonal close packed crystal structure include the magnesium, zinc and cadmium. So it look like a hexagonal sheets. Now which of the following model can describe the valence electron of the, so a sea of electrons. Okay, next, what is alloy? Why are alloy important? Alloy are the mixture of the two or more elements, at least one of the which is a metal. Brass, an example of alloy, and copper and zinc. Okay, so brass is the alloy of copper and zinc. So when two or more metal mix together and form a new metal, this is called alloy. Alloy are important because their properties are often superior to those their component element, such as sterling silver, 92.5% silver and 7.5% copper mixed together and make the sterling silver, is harder and more durable than the pure silver, yet it is still soft enough to be made into the jewelry and tableware. Okay. Another example I can give you, the car tire rim, so is made by the alloy as well. So the most important alloy today are steel. In the principal element of the most steel, in addition to the iron and carbon, are boron, chromium, manganese, molybdenum, nickel, tungsten and vanadium. Okay. Steel have the wide range of the useful properties such as corrosion resistance, ductility, hardness and toughness. So you can see here, these are the different metal combined together or different elements combined together and form the stainless steel, and steel is a alloy. Okay, now alloy can form from their component atom in the different way. There are two kinds of alloy which it can be formed, such as if the atoms or of the component in an alloy are about the same size. Remember, the component is the same size. Okay, component of atom same size. They can replace each other in the crystal. This type of alloy is called substitutional alloy. Okay, and if the atomic size are quite different, the smaller atom can fit into the interstice spaces. Interstice means space, okay, very small space between the large atoms. Such alloy is called an interstitial alloy. So explain why alloy are important and list the important alloy. Alloy are important because they often have the properties that are superior to those of the element from which they are made. Stainless steel is an important alloy because of its corrosion resistance. Thank you so much. This is the end of lesson number 7.3. Inshallah, next week we will do the chapter assessment.